video is a wrap. All right. So we have the physics problem, and this is where we start to get into the good stuff. Okay, so there's a lot about to happen in these real-world application problems. So if you need a break, pause the video and then come back, whatever you need to. But we are about to dive in pretty heavy right now. Okay, so here we go. The best temperature to brew coffee is between 195 and 205 degrees Fahrenheit. Okay, so coffee is cool enough to drink whenever it's 185 degrees Fahrenheit. The table shows temperature readings from a sample cup of coffee. And how long does it take for a cup of coffee to be cool enough to drink? So the temperature of this room is 68. Use an exponential model. All right, here we go. Let's go ahead and first work with these points that are going to build our equation. And when I say build our equation, guys, we've been given on all of these. We were given the equation here at 2 to the power of x, here. All of these functions were given to us. But now I'm going to, and over here as well, but now I'm going to take this data and I'm going to build a function that looks like this from that. And all the while, something that's very important is I want to know the room temperature is 68 degrees. Remember, by default over here, all of these other functions, their horizontal asymptote, their default horizontal asymptote was in fact 0. This is what it approached to right here as a default. But this one, it's not going to be the same. This one is saying it's not 0, it's 68. That's room temperature. So as time goes on and on and on and on and on, I'm approaching a horizontal asymptote of 68. That is so important, guys, because it can get a little bit confusing if you just use these points without using this information. You need to know what is that room temperature, because that's going to be your horizontal asymptote. Okay? This is that line that the graph will approach and never hit, but get close to as you go off to the right. Okay, so just like this, think of this example from before, like this value right here, which was a -4, would be room temperature. It would get very, very close to it, but it would actually never hit. Okay, that's just conceptual understanding right off the bat. All right, let's dive in. Here we go. This is how you do this, and this is very calculator extensive, okay? So let's come over here to the calculator, menu 1-4 to clear storage, menu 1-5 to clear my screen, and now it's been a minute, but we used to do problems with regression. We're going to go ahead and do that now. Here we go. Control Doc so we can add a page, those blue letters, add a page. We're going to add a spreadsheet. And we're going to add 0, 5, 10, just like our table, 15, 20, 25, 30. And these are minutes. Okay, so we could use any variable we want. I'm going to use X. You could use T for time. You can use whatever you want. Just keep track of the variables that you're using. The reason why I'm using X are because our default parent functions that we were looking at look like this. Y is equal to A times B to the power of X. Okay, and my input variable is here, and my output variable is here. So my X that I highlighted there in orange is the X here, and this Y value that I'm highlighting here is going to be Y here. Okay, so that's what I'm using as far as my values go. So looking at the table, I have 203, 177, 153, so on and so forth. So let me type that in. 177, 153, 137, 121, 111, and 104. All right, so let's go back, make sure we're good to go. Yeah, so here we go, guys. We're about to build this equation of what does it look like an exponential function. And this is where some confusion can come into play. Now, I did record this on your project video, but I'm going to quickly still show you on this video the 3 different ways that you can do this. So let's control add a page, data and statistics, We can say that this is x. We can say that this is the y value. And if I thought, yeah, that looks exponential, and duh, we're in the exponential unit, let's go ahead and calculate or analyze this regression as being exponential. And there's my equation. But guess what? This equation only works if it's adding 0 here on the end. See, this graph would approach 0, but actually never hit. Like y is equal to 0. But that's not the case with this. We know our horizontal asymptote is 68 because that was room temperature, and that's what we had to first interpret as our horizontal asymptote. Okay? So there's more involved with this in mind than just what we've done on the calculator so far. Okay? So this 68 does play a huge role into it because we can't just add 68 to this. That would be wrong. Okay? So yes, we could have done it from here. We could have done it from here as well. And I've shown you that with the project video. Or you could have done it from here by doing menu, statistics, stat calculations, and going down to exponential regression and saying input is X, output is Y. I'm not going to show you everything for the sake of time. And 196.57 is my A, 0.978 is my B, which is very similar to this one that you see right here. Okay? And yes, if you highlight, you can see all these points as you go through and see the ones that you plotted. Now, the way you're going to do this when there's a room temperature is you need to go back to your table and you need to create a third column. And you're going to say, I'm not using these. I need to use the ones that have room temperature of 68 in mind. So the way I do this is going to be 203 minus 68. Okay, but I don't want to leave it like that. I want the actual number of what that is. 203 minus 68 is going to be 135. That's what we're going to put here. Okay, so we'd put like 135. Then 177 minus 68, but this is too much typing. This is going to be 109. That's way too much typing. So a fast way to do that is to come right here, and we're going to say equals when this y value, so we're going to say y is subtracting 68. Okay? And then when I press enter, it will ask me, well, I'm going to overwrite this first of all because I have the ones already there. And I want it to do a variable reference. It's going to reference this y variable. And then I press enter. And notice that it not only did these again, but then it did all of the other ones. Okay, so the only points that I'm looking at now are 0, 135, 5, 109, 10, 85. Those are really the ones that I'm worried about as far as creating this exponential regression. Okay, so let's go ahead and do that all three different ways. Here we go. Let's first go over here and we're going to do menu, analyze. We're going to do regression. We're still going to do exponential. Oh, let me hide that exponential and redo it. So menu, analyze. We're going to do regression. Whoops, my mouse is a little touchy. So analyze, regression, exponential. And notice that it's going to show what we calculated before. Okay, so this is why we want to be careful of when we actually calculate this. Let me come over here and use this screen here. Okay, here we go. So column D, row 1, I'm going to go ahead and do it from here, and I'm going to show you again all three different ways. Statistics, it'll be stat calculations, exponential regression. My X input is X. My Y input is not going to be Y. It's that third column that I made. It's going to be Z. Okay. So now here is my answer. Okay. Which I can also go to the home screen and I can go ahead and press menu, statistics, stat calculations, exponential regression, where X is X, but my y value output is the z column. And there it is. So I have 134.516 or 517 is A times 0.597 or 0.956 is B, and it's raised to the power of X. You see that there are still no transformation in mind here. It doesn't have this horizontal asymptote shown. There's not like a plus D value or anything. But this 134 is definitely different than the one that I had when I wasn't using column Z. Okay, so I need to use this right here, and I'm going to go ahead and write it on my iPad, and then I will show my iPad screen here in just a bit. All right, so we have y is equal to the a value of 134.517. So I always do 3 decimal places because that's like what you'll do when you go to AP Calculus. And you can do 516 if you want, or round up if it's round upable, if you will, and do 0.517. And it's raised to, and it's multiplied by the B value, which is 0.956. And all that is raised to the power of X. Let me now come over here and show you what I just did. I wrote this equation here, but I'm going to do plus 68 because that's the horizontal asymptote that we know was created from the interpretation of the problem. This is the answer, okay? So 0.517, 0.956 to the power of X plus 68. That's how you do a room temperature problem, okay? So we know that over here we got the same thing, 134.517 times 0.956 raised to the X power. And over here we don't we don't have it showing because this is already showing the one that we've done prior, the one that we did before. Let me see if I can undo it or remove it. Let me see if hide. I think I just have to create another page. That's what I need to do. So let me show that one more time. Those of you who really like to learn technology, like me, that one will not change, but this is how we're going to have to do it. We would have to add another page of data and statistics, and here's where we would put X. Here's where we would put Z, and then from this graph. That's why it wouldn't work from before, because it had that same Y value of Y here. So now it'll be menu analyze, regression, exponential, bam, there it is. There's our equation. But again, you see, just like on these other pages, it doesn't, oops, not that one. Here and here, it doesn't show that horizontal asymptote. You have to add that 68. But this right here, 134.517, does in fact match what we got right here. Please, please, please don't forget that horizontal asymptote, otherwise known as room temperature. All righty. So we are almost done, guys. This last problem, and then we are done with this video. The other 2 days, or the other 2 videos are going to be very, very short because most of the content is on this video. All right. So it says a casserole recipe says to bake the casserole until the center is 190 degrees. Okay. So until the center is 190 degrees. And then let the casserole cool to 130. Okay, so we have at time 0, we're at 190. 5 minutes later, it's reducing. 10 minutes later, it's still reducing, and so on and so forth. It says, given a room temperature of 71, meaning that as time goes on, this one will never hit 71. It will approach, but it will never hit. What is the exponential model for this data? And then, how long would it take for the casserole to cool to the desired temperature? I think I might have skipped that part over here. Yep. How long does it take for a cup of coffee to be cool enough to drink? So we want to know, how long does it take until it gets to 185 degrees? There me show you that real quick before we keep going to this other problem. I'm going to store into the calculator this function, and then I'm going to allow the calculator to solve what x value, that's the time, when it would be 185 degrees. So we want to find the blue highlight. Okay, so the 185 is our output of what it would be in the end, and x is what we're looking for. All right, so let's go back over here, and let's go to our very first page. Good practice, menu 1-4. Trust me, you want to do this, otherwise it is going to give you so many errors, as you can see right now. If it does give you errors, the best thing for you to do from where you're at is to go ahead and press home to menu C, OK. And it's basically just going to clear your calculator. Okay, I'm just going to start with a new document, and then I'm going to go ahead and type this in. Here we go. We want to do menu 3-1, 3 for algebra, 1 for solve. And we want to solve when 185 would equal the equation that we got, 134.517 times 0.956 raised to the power of x, and then plus 68. Now, I'm going to tell it what to look for by doing comma x. That means it's going to solve and do all the work for me of solving for that x value. And there's my answer. Okay? Now, this is my answer, but to be more accurate, we need to make sure that the values that we put in are to 6 decimals and that we're only rounding the answers to 3. So back over here, this is the answer equation. That's why you saw me do 3 decimals. But if I'm going to use this to find the answer to something else, I need to unround these and go back to the 6 decimal places. Okay? For the sake of time, I'm not going to do that on this one, but you would unround these and show all the decimal places for those, the 6 decimal places. Like, for instance, it could have been like 0.517 and then 123, and then 0.956, 123, so that you have a total of 6 decimal places. And then this you would round just to 3 decimal places. Okay, so answers you round to 3. This was an answer equation, it's rounded to 3. But if I use anything like this to obtain another answer, I have to unround and then round that new answer from this unrounded piece. Okay, rewind that video if you need to understand that of what I just said, but that's how we're going to calculate per time or per accuracy. Okay, so this wants to know how long does it take for that to happen, and we're gonna go ahead and do it after 3 minutes. So let's just round to the nearest whole minute, and we're gonna say about 3 minutes for that to happen. So about 3 minutes. Just going to round to the nearest minute for it to take. It takes about 3 minutes. And that's the time that it took. Okay, how long did it take? There it is. All right, so now let's go back to the last one that we had already started. Again, we're trying to approach 71 as the room temperature. This is the data set that we're given as far as the incremental times. This data set is very similar to like the data set points that you got on your project. And just real quick, the center of the casserole is 190. Let the casserole cool to 130. We know that the room temperature is 71, and we want to find that equation. So I'm going to use these points and go ahead and go quickly to the calculator. Here we go. Menu 1-4, menu 1-5. And we're going to add a calculator spreadsheet page and then type in the data that we have, 0, 5, 10 to 20. So 0, 5, 10, 15, and then 20. Those are all my x values, okay? And then over here are my y values. And the y value that we were given are 190, 139, 110. So here we go, 190, 139, 110. 95 and 88. This is a room temperature type of problem, so I'm going to use Z. And I'm going to say this is equal to variable Y minus 71. And the reason why we use 71 this time is because room temperature is 71, not 68 for this problem. So when I press enter, it'll say, are you talking about the column or the variable? I want to refer to the variable Y. And there it is. So now all I care for are the X and the Z's. Okay, so 0, 119, 568, 1039. That's what I'm telling the calculator to calculate. Okay, so let's go ahead and go to, and you could use either one. I like the picture. So I'm going to go ahead and go to the data and statistics. It's a good visual for you to remember. You're using the Z values. Okay, and these Z values, you can say menu, analyze, regression. It is exponential. And we have to remember to add the room temperature here on the end, okay? So I'm going to use this right here as my equation answer. So 112, let me go ahead and write on my iPad as you are looking at it on the screen. Y is equal to 112.319 is going to be multiplied with 0.906 raised to the power of x, and then finally adding a room temperature of 71. There is my equation right here. Okay, again, this will not be shown on the calculator as you cannot see it here. All right, so, but I need to answer part B. When is it going to be cooled? In other words, when is it going to go all the way to 130 degrees, which it said would be cooled degrees? Okay, so again, like I said before, we have to unround these and go to 6 decimals. Okay, so let's go ahead and show you from this screen. You could do menu 6 and you can float this to, let's say, 9 because it was at 6. I need 3 more decimals. Let's make it my default, and there you go. Now I have 6 decimal places and more than 6 over here. Okay, so however you want to adjust that, if you wanted to just say the setting was float, then it'll give you all of them. Okay, but don't say auto because it won't necessarily give you enough that you need. But look at that, it gives you a lot of them, and all you need is 6. So again, as this is showing, I'm going to put this on my iPad. 112 point, here we go, 319427. There's 6 decimal places. The B value, otherwise the base value, is 0.906 and then 0.46 raised to the power of x. We can't forget our room temperature. And we want the calculator to solve when this is equal to 130. So solve when all of this is equal to 130. And I'm going to solve for x. So let me show you what I've been doing. Wrote all those to 6 decimals, wrote all that, and I want it to equal this 130 up here. Whoops. So I'm going to go ahead and write that over here. When is it equal to 130? When is all of this equal to 130? And then we see that we have comma x because x is the variable in the equation that we're actually wanting the calculator to do the work for us and solve it out. Okay, so let's go to the calculator. And just FYI, guys, if you did it from here, menu 6, stat calculations, exponential, and you did x, and you did z, you're still going to get that same answer, okay? And it already gives it to you in a lot of decimal forms, just FYI. You could do that same thing over here. Just want to make sure this first day is very in-depth as far as the tools that you're going to need. And from this column right here, whoops, you're going to say menu. You're going to do statistics, stat calculations. Whoops, I don't think I did linear regression. Let me try that again. Menu, 4, 1, exponential is A, X, and Z. Sure enough, there are a lot more decimal places that are viewable. Okay, so on certain screens, they have a lot of decimals that you don't have to do what we did on this one, but I just still want you to learn the calculator. I want you to be familiar so that you can find the calculations. Here we go. Menu, 3, 1. Solve when 130 is equal to 112.319, 427. Again, that's those 6 decimal places so that we can get an answer. And it's 0.906046, and it's raised to the power of x. Okay? And it's adding 71. Now, notice this x is bolded. This is where you can actually get some errors. Okay? Errors can actually occur when it's bolded because the x, the reason why it was bolded is it's registering this x right here. And yes, it can error sometimes. Sometimes you might get away with it not erroring, but a lot of times it will. So what I like to do is go up here, press Control C, okay? And you can do that right here, Control C to copy. And then like clear everything up. Here we go. Menu 1.4, you're just clearing storage. Menu 1.5, and if you press X again, it's still bolded. The reason why it's bolded is because you still have it active on another page. So if I come here and let's say that I want to delete those other pages, Control Up can delete those pages, and just press delete right here. And then just press enter or just press that like keypad right here, and it'll basically just close. They almost look like browser windows so that you go to your normal page. Pressing X, it's still bolded because you haven't yet menu 1.4 storage. Then menu 1.5 clear screen. Now X is not bolded. Okay, so there will not be a risk of you inadvertently using a stored X from some other page. Okay, so Control X is to undo or cut, that is. Control V is to paste. So when we do Control V, it will paste what we have, what we had copied before. When we press enter, you see that there was no change on this one. That's not always the case, guys. I just wanted to show you because it will error and glitch out sometimes, and you're going to be like, why is it erroring? What am I doing wrong? And so on and so forth. You got to know as much as you can as far as those errors, okay? So between 6 and 7, so we'll say the time is x is about 6.525 minutes. Otherwise, between 6 to 7 minutes is what it took. All right, guys, so that is a lot. Okay, so if you do need to pause, rewind, take some breaks or come back, whatever you need to do with this video, that is totally fine. Just make sure that you are held accountable for all the information and that you review anything that you have to. So to finish this video, I'm just going to quickly show you these marble slides exponential Desmos activity. Please do this because it will enhance your learning for this unit for sure. And all it is when you click on it, it takes you to like 24 different models that when you launch these balls, your goal is to shift this graph to basically capture all the stars. So when you've succeeded on one, just scroll over to the next one. And it's like, what do you do to this equation in order to, when the ball drops, you would get all of these? Okay, so this one I could probably slide to the left a little bit. So let me slide this to the left. So instead of going 18 to the right, I want it to go 15 to the right. Okay, oops, 15. But maybe 16 because then I won't get that star. There we go. So transformations is really what you're looking at, just to make sure that as you are looking at the C, the A, and the D values, in order to make this happen, what is it that you're learning as far as stretches, compressions, reflections, and so on and so forth. Okay, so yes, you can jump around, you can try them out, like launching this. You didn't really have to do anything on that. This one, actually, I've already done these. That's why they're working, because I already updated them from what they were originally set to. If I press this and press reset, it will go back to the original one. Okay, so let me undo that. So pressing this edit list and then reset will reset it back so that you can start from scratch. So if you start doing numbers that throw it way off, this will help you in that regard. So when I launch it, nothing happens. But when I start changing things, okay, with this graph, like you saw before, it will in fact make it happen. All right. So you guys have an awesome day. Again, rewind, pause, take some notes, whatever you need. I'll see you next time.